Good morning, class. So today we're going to be continuing our discussion on vectors. So remember the difference between scalars and vectors is a scalar is just a magnitude, whereas a vector is that magnitude with an added direction. So that makes it perfect for problems involving velocity, because velocity compared to the speed, where speed is just the magnitude, velocity then also includes a direction, like north, south, east, west. So I'm going to be borrowing this problem from Khan Academy. If you wanted more information on vectors, you can check out their videos. And this is one more problem that they have that we're going to be working through together. So let's read through it. So Amelia flies her airplane through calm skies, no wind, at a velocity, speed, and direction. V1. The direction of V1 is 15 degrees north of east, and the speed is 180 kilometers. So if we were to draw out cardinal directions, so north is up here, so east, south, west. 15 degrees north of east. So that means this way. Call that. So 15 degrees north of east, the magnitude of 180. Then, eventually she enters the windy part of the atmosphere and finds that the plane now moves at velocity v2. The direction v2 is due east, and that speed is 150 kilometers. So the plane ends up in this direction, east, the magnitude of 150. If you notice, one mistake I made right now is, if this magnitude is 150 and this magnitude is 180, shouldn't this vector be larger than this vector? Yes, if we're trying to be consistent. So let me enlarge this one, because I don't want to make things smaller. And that should be fine. Right? As long as we understand that this vector has a greater magnitude than this vector. And then that means there's some resulting wind, which we can represent with it by this blue vector that gets us here. So it slows this down, and what we're going to be trying to do is calculate that vector. So the very first thing we want to try to do is write the vectors. So let's look at 180. We're going to look at the first one, V1. So V1 can be written as 180, the magnitude. If you guys remember, if we have a triangle, you can always make that into a right triangle. It would degree 15. Hypotenuse 180. We have x and y. X and y. Right? Remember, but from SOHCAHTOA, then we can see that the adjacent side, the x component, would be 180 cosine of theta, which in this case is 15, so cosine 15. And we can see that that y component is going to be 180 sine 15. Let's make that. So let's plug that into our calculator, which I do not have open, so let's open that up. So let's do 180 times cosine. Whoop, that's not how that works. So 180 times 15, make that into cosine. That's what we wanted. This is the value of cosine. So now we're going to equals, and that's going to give us our value, 173. So first vector has a value of 173.867. Our x component. Right? And then our y component would then have 180 times 15 sine of that, 46.587. Nice. Now let's find out where our resultant vector is. So in this case, the red one, where we ended up at. So we have this triangle. Does it have an x component? Does it have a y component in this case? It's just going straight east. So in this case, if we were to try to draw a triangle, we would only end up with a straight line. And on the grid, you can see that it would have, since it has a magnitude of 150, this distance here is 150. This distance from here to here. And there's no y component. So this one's easy enough, and we're done with the two vectors. And then we can relate these two vectors together. Let's call this one, I guess, v3. Continue the pattern. So in this case, we could see that v1 plus v3 equals v2. From our picture, you can see you can go up, down, and go here. Or even if you had started with v3 going this way, and you went up v1, you would still end up at where v2 is. So we can shuffle things around because we already know what these two are. We want to find v3. So let's subtract v1 from both sides. Remember, we're allowed to. So that would leave us with v3 is equal to v2 minus v1. v2 minus v1. So when we're subtracting, remember, subtracting is essentially just adding by the additive inverse of that vector. So this is the same thing as of adding v2 plus just minus v1. So with vector addition, then we're just going to add the components together. So I'm going to add up the two x's, and I'm going to add up the two y's. Well, the minus versions for v1. So in this case, it'll give me... Okay, so I've made a mistake, and I'm going to continue now. So we're doing v2 plus the additive inverse of v1. So in this case, 150 plus negative 173, right? So we're subtracting. So using our glorious pencil math, this will be negative 23.867, comma. Now we're going to be doing 0 minus this part, so it's just going to be a negative version of this. So minus 46.587. And does this vector make sense? Well, if we were to draw it, we're going down. It looks up like this, right? Because it's negative x component, negative y component. Y is larger than the x, and that kind of fits with our graph, with our drawing that we had before. So now that we have the vector itself, we need to answer the question: what is the speed, and what is the direction it's going? In order to figure out the speed, what we want is the magnitude of the vector. To find the magnitude of the vector, you can always think of this as a right triangle. Right? We know the x component, we know the y component. So by squaring and then doing the square root of the sum of the two squares of the two components, then we could find that magnitude. So that's exactly what we're going to do now. We're going to do magnitude of v3 So to save me from writing the numbers, I'm just going to put v3x, referring to the x component, and v3y, referring to the y component. I want to square both. So calculator, let's see. So we're going to do 23.867, and it doesn't matter that I'm not going to make it negative, because once you square that negative number, you're still going to get that positive result. So positive plus 46.587 squared. So that is their sum. And now we want the square root of that. Square root button. Perfect. It's 52. Seems like it could make sense because 50 times 50 is 2500. So 52 should be larger than that. So 52.345. And because this is a word problem and we care about units, well, in this case they already gave it to us, but we should be checking. So 180 kilometers per hour, kilometers per hour. Subtracting kilometers per hour from kilometers per hour, we should get kilometers per hour. And that is our speed. So now to find the direction that the wind is blowing. In what direction is the wind blowing? Well, that refers back to this vector. We care about this angle now. So to find this angle, we can use, for example, anything from SOHCAHTOA. So for example, I could use tangent, where it's the opposite over the adjacent, and that is the y component over the x component, which we already know. That's one of the first things we had found. So that means theta would then be equal to tangent inverse of negative 46.587 over negative 23.867. So then the value of that, I don't know how to do it on that calculator, so over here, I have 23. So 7, close my parentheses, I get syntax, that is equal to 62 degrees. They want their answer to the nearest degree, so this is enough. So this rounds to 63. Rounds to 63 degrees. But wait, does that make sense? 63 degrees would be going up this way, when our actual angle is going down that way. Remember, that's because cosine inverse, in this case, tangent inverse. Tangent inverse is the first and the fourth quadrant, so it's not going to tell us this. So in order to do that, to fix that, we're going to add 180 degrees to get this angle that we want. So plus 180. So this is equal to 243. So now let's input that answer, 243. And I didn't write it, but they had it for there. Degrees, units are important. And that's everything that the question was asking. So now let's check our answer. Smiley face, done. Awesome, so we were able to finish our first video. I hope I was able to help you understand the relationship between vectors and velocity a little bit better. Especially when it comes to word problems, it's important to be able to dissect information and get the correct angle, especially with direction. So pay attention if they mention like a bearing or anything like that. Please leave a comment with any feedback or suggestions, and if you would like to see any other videos related to anything else in math, whether it be for algebra, geometry, or pre-calculus, whatever it may be, please let me know and I'll be glad to make one as soon as I can. So, thank you for watching. Have a good day. Bye.